Welcome. Today is the ninth video. Today is the ninth video of graph theory, and where we'll study prims, where we'll study minimum spanning tree prims algorithm. So prior to this, in video number 8, if I'm not wrong, in video number 8, we have discussed a question to calculate minimum spanning tree using prims algorithm. So we have seen a question, we have solved a question using Prim's algorithm. So again, I'm saying I always follow a reverse engineering, means that I solve the question first and then we'll discuss the algorithm, because after solving question it become very easy for you to understand what algorithm is saying. Fine. So if you are directly coming to this video, I request you kindly accept my request that kindly watch video number 8, so that it will become very easy for you to understand Prim's algorithm. So let's start with the Prim's algorithm. Here is the Prim's algorithm. Here you have a graph. This is the graph which we have solved. We have taken this graph, we have solved this graph, we have calculated minimum spanning tree of this graph. So let's start how this algorithm is working. So let's start. Okay, so we have also created one matrix. So if you have seen, again I'm saying, if you've seen video number 8 of question of Prim's algorithm, it will become very easy what this this matrix is all about. And then this is the final, this is the graph in which I'll make a changes. Fine. So what you have to do, you have to find minimum spanning tree. You have given a graph, you have given a weight, and you have given a source. Source means from where you have to start. Suppose you have to start from node 0. It is given. Fine. For each u, that is for each vertex belong to vertex of graph, what you do, make key of u, make key of every vertex infinity. Without thinking one, make key of every vertex infinity. I have made it. Pi of u, pi means parent of u. Parent of u is nil. Since there is, we cannot say who will be the parent of 5, who will be the parent of 1. I cannot say. So parent of every is nil. I'm not discussing. So I have made those double line was considering as a parent. No, were considered as a parent. So I'll not use those double line now. So it's still nil. And key of source is 0. So this key of source is 0. So what I did, I've explained you, make source as 0 and all other node as infinity. These 4 steps from 1 to 4 are called, these 4 steps from 1 to 4 are called initialize a single source. These are called initialize a single source, where what you are doing, for every vertex, for every node, you are making source as 0 and all other node as infinity. This is called initialize single source. I'm writing fully initialize single source. Initialize single source. Fine. Okay, now what I told you, that insert all the vertex in queue. So I have made this queue. Fine. So I've made this queue. Let me change the color of my pen. I've made this queue and I have to insert all the vertex. There are 7 vertex from 0 to 6. I've inserted all the vertex in queue. No, why? Now 6th step is saying while queue is not empty. While queue is not empty, you start following these steps. First of all, extract minimum queue. So now fill first. The weight of 0 is 0 and all other vertex are infinite. I'm solving I'll solve only 1 and 2 step, because I've already solved all these things. Do extract minimum. I've just forgotten to write one thing over here. So this is u. Here you have u. Do what you are inserting in u, extract minimum q in u. So what is minimum q here? 0. So what u becomes 0. So you have extracted 0. You have extracted 0. Fine. Then for each v, all those vertex which are adjacent to u, what is u0? All those vertex which are adjacent to 0. What are those vertex which are adjacent to 0? 5 and 1 are adjacent to 0. What you have to do? Do if v belong to q, are this 5 and 1 are in q right now? Yes, they are in q except 0, as we have extracted 0. All are still in q. Are they part of q? Yes, this become true. And weight of uv, suppose I'm consider this weight is less than kv. Is this weight is less than this? Yes, this weight is less than this. This is also true. This is also true, and this is also true. If I'm taking v as 5, so 5 is a part of q, and weight of 0 and 5 is less than weight of 5. Yes. So then what you do? Pi u is equal to u. So what you did? You make a double line. Fine. And what you do? Key u become wu. So the key of it's not u, it's v. Key of, and it's v, it's not key v become u, and key v become wu. So this v's node 5 will become what wu, 05 is 10. Fine. Again, are you over with, the adjacent node? No, you still have one more adjacent node, which is what are different adjacent node. One adjacent node was 5 and one adjacent node was 1. Now you consider 1 belong to q. True, yes, 1 is in q. Is weight of 0 and 1 is less than weight of 1? Yes, it's less. Now what you do, make pi of 1, that is parent of 1, as u. This will become double line, and weight of uv, assign the weight of uv to key v means what here, so you assign 28 here. Similarly, what again in next step, so this step is over, you will again go up, you will find, is q infinity, is q empty? No, q is not empty, still there are so many elements in q. So what you do, extract minimum q, which is the, so what changes you take place, it took place, 5 is now 10 and 1 is not 28. So extract minimum. What is minimum? Node 5. So you extracted node 5, you extracted node 5, fine, you extracted node 5, again you find adjacent of 5 and you start making those changes. Fine. So this is what I wanted to tell you. I just wanted to rectify it. It is v, it is v, and here you have u. Fine. Okay, so this is what algorithm is all about, and you keep on following the same step, and at last you will find that q is empty, and you will find a what, spanning tree, that is minimum